Hello and welcome to the Python programming classes again. In today's video, we are going to have a discussion over Python collections. So there are four collection data types in Python programming language, as you can see: list, tuple, set, and dictionary. Now, list is a collection which is ordered and changeable. That means we can change the items in the list, and it allows duplicate members. Whereas tuple is a collection which is ordered and unchangeable. We cannot modify the content of tuple. It allows duplicate members again. Set is a collection which is unordered and unindexed. No duplicate members can be present in set. Now dictionary is the collection which is unordered, changeable and indexed. No duplicate members. Now what I read as of now is the definition of list, tuple, set and dictionary. Now how these things are in working, I'll be showing that. Now with all the collection data type, choosing the collection type depends on what are the properties of the collection data type, and what is my purpose, what are our purpose, and for what particular application or what particular programming we are utilizing that. So it depends on that. If you want the content to be changeable, then you can go for list. If you want that content should not be changed, it should be immutable, that means you look for tuple for a solution. So now depending on the choosing right or wrong or different type of collection data type, you can increase the efficiency, you can increase the security, or you can work like that. So the first and very important collection data type is list. So we are going to start with list. Now list is a collection which is ordered and changeable, we have earlier read. Now the first important part is whenever you are going to declare a list, you need to use a square bracket. Okay, one example is already done for you over here. I have created a list of fruits: apple, banana, cherry, and when I try to print it up over here, the list is printed, right? So let's say create a list again, and this is the particular thing that you have to keep in mind, that whenever you are going to declare a list, use this square bracket, and inside the bracket you can start with one element to n number of elements, right? So earlier we have, in the example set, we have done for string data type, all are strings. Let's say do for integers 12, 34, 56, let's 58. Okay, and now if I want to print my list L1, that is right. Now we have done a list of strings, then a list of integers. Now list is like arrays, which we have studied in programming earlier as well. Now there was one limitation of array, and that was that in the array you can only declare similar type of elements. Like if you are going for the string, all should be string. If you are going for integer, you go for it. But in case of list, you can have different data type elements in my list, which is here allowed in Python. Let's declare another list, and as I said, let's try to assign some integer, then let's say Sarah, and then say 3.14. okay, so print the list L2. So as I have written one integer value, one string value, and one float value. So let's see what is going to happen over here. See, so here is a note which you have to accept as, let's say, write a note in front of you itself, and the note is that list can hold different data elements, right? This is what is very important to know. So by declaring different type of lists, we can have one thing for sure, that list can hold different data elements. Now the next question comes, that how do we access the elements in the list, right? So this list, as I say, that it works as an array. So we have referencing index numbers, and definitely when I'm talking about indexing, the index part will always start from 0. Okay, so one example has already been done for you, like for the string part, which I have earlier done, that if we try to access the index 1, which is the second element, because 0 for the first and then second element, it will be like this. So let's try another example here live. We have created this list, right? So let's copy the same list over here. Let's say, okay, this is the list, and if suppose I want to access the element of L1, which is, let's say, fourth element. Do we have 4 elements in this? Okay, third element. Now 3 is representing the fourth element. If I would have written 4 over here, it would have went for overflowing, right? Which is not here, present here. Clear? So this is our third element which we are looking for. Now we have negative indexing as well, but before going into indexing part of that, we can have certain methods over here. So let's say, let's have another one which I'm talking about, append in list. Okay, now L1 is already existing above, so let's say if I want to append one more element to it, okay, I want to append 100 into it. And remember, whenever the list, we perform any changes in list, whenever we have any operation on the list, a new list will be generated, right? The content will be modified into the list. So let's print it. So what should happen? Earlier we were having 4 elements, and by appending I should have 5 elements in my list now, right? We can have another example of, let's say, insertion. Insert element in list. Okay, so L1 is already there, so I want to insert in the list. Now in inserting in the list, as you can see in the method also, we need to have information about 2 things. That what is the index, means the position where we want to insert, and the object, that what value we want to insert. Let's say I want to insert on second index, and I want to insert 66. Okay, so clearly in this example 0, 1 and 2, right? This is the location where 66 should be added. Now in order to check, we need to again print the same list to know whether this function has worked or not. So what output we are expecting over here is that the 66 will be on the second index, that is third position. So I think it is clearly visible over here. Now we have done append, we have done insertion. We can also remove certain item from the list. Let's try that example. Remove item from list. Now removing the item, let's say the same list we are having, and I have to simply write a function of remove, and in remove you have to provide the value, right? Let's say we have the values which is, let's say I want to remove the 78. Okay, so I'll write 78 and then again print L1. Okay, so let's execute it. Clearly difference is there. 78 has been removed from here, right? We haven't given the location over here. We have just removed the item and the value of item is done. Now we can have another question in mind, that suppose if I do not know the value and I want to remove the content from any position, then what will happen? So let's say removing the item from removing item from list using index. Earlier we have done with the value. So for that purpose there is one operation or function, pop. I think you must have studied in data structure in sticks the pop operation, and the pop operation was literally it just take out the last element of the stick, right? Now here if we provide the index, let's say this is my 12 on my 0th index and 34 on my first index value. So if I write 1 and then if I print L1 again, so what should happen? This 34 should not be present in the list as of now. See what output be. Okay, this is the method of removing item from list using index. Okay, earlier we have done that part using value. Now furthermore operations we can have, let's say what we can do, we can okay, we have already done. Fine, let's try this one. L1 dot, okay, it's not typing. Removing last element from list. Now L1 dot pop. Now remember so that earlier we have used a value to remove from the list, then we tried to have a pop operation and a pop function we have used over here, and this has been done using the index part. Now suppose I don't want to use a index value, and if I do not write anything in this braces of this pop function, so what will happen? The last element, whatever be it is, the last element from the list will be removed. Let's see the answer. Fine. So I think we have done methods. Okay, yeah, one more method we can do, like removing multiple elements from list. Now suppose if we want to have as of now what we are doing, we are just choosing one value. Using value we are removing, we are using index to remove things, we are using one value using the index number, we are removing one element from the list using the pop operation using the default last element, And if we want to remove a much number of elements from the list, now clearly we have only left out with only 3 elements in my list. So I'll first append something in my list. So L1 dot append, and let's say 23 comma 4. 34 was 34 we have removed, then 78, then let's say 99. Okay, so by this append we can always have add something to the existing list. Append method is to, and let's say L1, let's first print it. Now what it is giving. Okay, fine. This is not the way we can add. With the append method we can only append one element. Fine. So that means every time I have to just put over here the value. Fine. Elements I have been increasing. 99, let's say add. Okay. I'm just doing that particularly to have more number of elements so that we can remove multiple elements from the list. And suppose if there are only 3 elements, we'll be removing all of them. I don't want that. Now we have 3 and 3, 6 and 7 elements indexing from 0 to 6. Now if I want to remove multiple elements from the list, we'll be using a del method. Delete from, del stands for deleting. Delete from the list, and now you need to define the indexing, that from where to where. We have already studied about the range part, so let's say from the index value 2 to 4. Now in the index, as I have earlier discussed, that the last value of the range will be ignored, so we'll be removing element number 2 and 3, not included 4, right? So print L1 again, and clearly let's do that exercise manually first. That the range is starting from 2, that means 0, 1, 2, that means the value 56 we are starting looking for, and till 4th, that means this is my second position, 3rd and 4th will not be done. So 56 and 23 must be removed from the existing list. So this one was the earlier version. So now I'm going to execute the cell and see. Now you must have one question in mind, that okay, because we have executed the same line of code of append as well, so 101 is added twice, right? After addition we have printed one time, and then after remove of 2 to 4, that was 56 and 23, which is clearly removed from our program, right? Now for the same list, let's see, let's make this part as a comment, because again it will be appending the same item in the list. If we simply, okay, let's create another one. If we simply start by deleting, let's copy it. If we simply start by deleting we provide the index starting and we do not do such things, what will happen? It will remove all the elements starting from the index 2, right? So let's see what is the output. The remained list was earlier L1 was 12, 66, 78, 99, 101, 101 2 times, and now we are deleting from second position to all, and here 0th index first and 78 will be the second index position. From that the all elements have been deleted, right? So these are the pretty good methods of which we can perform over the list. Now as I tried to do that append part for multiple values and it gave error, so just reminded me of that because I was thinking it was happening. So let's see, adding multiple values to list. Now for that purpose, what we have to do, we have to use the method of extend, and in the method of extend, then inside we can write let's say 33, 44, 55, 77, 88. Okay, and if we do so, let's print it and let's see what is happening over here. So earlier the list was remained with two elements, 12 and 66, and what we have done, we have extended it. So in the same order, 33, 44, 55, 77, 88 is kept over here, right? So you have to remember that while you want to insert one element, you want to append one element, add to the list, you will use append method, and if you want to have multiple values to the list, if you want to add, you have to use extend method. Now we have all the aggregation functions as well present with the list. Aggregation. Now aggregation comes with let's say minimum, maximum, sum, and okay, these are the most popular aggregation functions. So minimum of L1, and let's say then maximum of L1 I want to print, and then the sum of L1. So okay, I need to write a print statement over there. Okay. So the operations will be now going to happen over the rest list, which was 12, 66, 33, 44, 55, 77 and 88, and it has came with aggregation functions like minimum, maximum, and sum of the list has been calculated. Now there is one more thing, sorting. Okay, sorting of list. You must have studied in case of C programming or data structures, and people were very obsessed of these numbers that this list is given, make a sorted list using bubble sort, using insertion sort, using quick sort, using merge sort, and blah blah. Now Python has done an easy task for you, and it has just simply created the sort function for you. So you need to only write the name of the list, and then you write sort, and it will be sorted out, right? So first is checking the sort, whether it has been sorted or not. Let's say print L1 again. So if you remember, so in the earlier method 22, 60, 12, 66, 33, 44, and the rest of the things are sorted, but the 66 is not on the correct position. So for the sorting part, it should be on the correct order. Yeah, now it is 12, 33, 44, 55, 66, 77 and 88. This is what is happening in case of sorting. So I hope you must have understood different methods on the list. Now there is one more thing which we want to add up, that is negative indexing. Negative indexing means beginning from the end, and -1 refers to the last item, and -2 for the second last item. We have already done at the part of time of data variable declarations and assignment part, and slicing of the values, right? So let's do that in the runtime for the existing list L1, right? Make it downward and then come again over here. Okay, so what we want to do, we have the list, so I want to have print of the okay, I have to first give the list name, print of L1, and if I write -1, so clearly the element 88 should be printed, because that is the last element, right? So this is what is happening. Now in case of ranges of indexes, you can simply specify the range of indexes by specifying where to start and where to end. We have already done for the range part in case of deletion, right? While deleting we have given the range. So let's do it with the code part itself, that if I want to have a range print, we have already done so, but let's see, L1 from 2 to 6, let's say. Do we have till 6 elements? Yes, we have, which has been printed for the range. Now by leaving out the start value, the range will start at the first item. So let's check this as well, that in case of our list, if I want to print the list, and in the index part if I simply colon and 6, that means it will be starting from first position to the 6th position. So let's see, it is happening. Yes, fine. The next topic is, by leaving out the end value, the range will go on to the next end of the list, right? So we have already done that part earlier as well, but for the purpose of demo, I'm just doing it simply because this is simply a print statement. And if let's say from 4th position, and I'm not writing the end location, so okay, it is starting from the 0 1 2 3 4. 4 is 67 to end, that is still 88 we have printed. Now range of negative indexes. Now clearly an understandable part is that whenever I'm talking about the list elements, suppose if these are the list element, okay, if these are the elements, let's start with the print statement itself, negative of the indexes in this. Fine. So first simply print. Now what is the current value of L1 as of now? The value is this, right? We have 3, 6, 7 elements in this, ranging from 0 to 6, right? So now what is the expectation over here, that can we access the list in the negative index part, right? So let it be here in the printed format so that we can have now print L1. And like positive indexing, what we are talking here about, that we start with the negative index. Now this last element 88 is having -1 value, then this is 77 is having -2, then -3, -4 and -5. Now the order of printing is always in this direction, that from -5 I want to print till -1. Okay, let's do it. -5 to -1. Let's see what happens. Fine. 44, 55, 66, 77, 80. Now some of you must have a question, why didn't we started here in the -1 and ended with -5? So now understand the part that the index ranges always start from minimum value to the maximum value. Now, -5 is lesser. Now let's try for curiosity, what will happen in case if we try to print in such a manner that, let's say, -1 to -5. What will happen in this case? See, we didn't came up with any results, because what happens in case of ranges, this last element was -1, right? If we started from -1, that means we can always go for range in positive direction. Fine. From -5 to -1 we can travel in this direction. Now if I would have written over here till 4, let's try it again. Because the index has started from -1, that means we are not looking for the range. The negative indexing should always end in such a manner that we can traverse somehow. Okay, so what we will be doing, okay, now let's do it for -6 to -3. What I am demonstrating you is that the list will be going in this direction, but the indexing is negative. Now people might have think that if we are starting from -1, that means we are traversing backward direction. No, the indexing is only for the part of if suppose we have a list of having thousands elements and we want to print some last 10 elements out of it. Now we can utilize this negative indexing by counting from the reverse direction, but the printing will be done in such a manner. The elements will be chosen in from left to right direction, right? So we will always have the lower value starting range and some higher value ending range. And we have already tried -1 to positive value, which is not possible. For that purpose we can go for positive indexing starting from 0 to some positive values, right? So this is the part of I think I should end over here for this video. Some more applications over lists, some more methods and functions we'll be covering in the next video. That's all for today's session. Thank you so much for watching.